We are moving on to questions on force, density, and pressure. And here, this is the first question, which is about turning effects. The question says force shown in the diagram has a moment of 40 newtons about the pivot. So this force is causing a moment of 40 Newton meter about this pivot. This is the pivot, right? And what we need to calculate is the magnitude of the force. So what is this force F? We need to find its magnitude. So we know that turning effect, that is moment, is equal to what? Force into perpendicular distance from pivot. Perpendicular distance from pivot to where? To the line of action of force. Now the line of action of force at this point in time is this one. So I see that this 2 meters is not perpendicular, and in moments I need perpendicular distance. So what I'll do next is I'll just resolve this force F into two components. One would be this component, and the other one would be this horizontal component. So F has two components. The component along the angle is cos theta, so this is F cos 45, and the force opposite to the other one is F sine theta, so it's F sine 45. Now I see that this distance from pivot and this force F sine 45, they are perpendicular to each other. They are perpendicular to each other. I can take these. I cannot take F cos 45 because its perpendicular distance from pivot is 0. It's parallel to the distance from the pivot, and that would cause no turning. In other words, this force is directly acting on the pivot, right? So I'll just do the calculation. This would be F sine 45 into distance 2 meters, and this is equals to what? 40 Newton meters. So it would come up to be 40 divided by 2 is equals to F sine 45, and that would be F is equals to 20 upon sine 45. And when we put the values in calculator, this will lead to 28.3, that's 28 newtons. So my force here is